Good afternoon and welcome to today's Expedition 32 post-spacewalk briefing. Today we have with us International Space Station Program Manager Mike Suffredini, Ed Van Cise, the Flight Director in charge of the spacewalk today, and Keith Johnson, the lead spacewalk officer for today's activities. We'll start off with some opening statements and then we'll move on to your questions. Mike?
Well, good afternoon. I never thought I'd be saying this, but I've never been so happy to have 7 or 8 power channels on board ISS as I am today. And I won't go through all the details of the EVA. I'll leave that to Ed and Keith since they lived through it. But we do have, as everyone knows, we've got the MBSU-1 installed and activated. It's acting very well. And over the next couple of days, we'll integrate all of the components back in that MBSU feeds so we get closer to a nominal config. In addition to that, the team was able to take the time to change out the SSRMS boom camera, which put us in a really good configuration for all the operations we do utilizing the arm. While it was difficult to live without this boom camera, we can, and we're prepared to do that if we had to. But today's EVA went as good as you could hope for, and once we got the MBSU installed, the crew and the ground team decided they had the time to go ahead and get the boom camera replaced. So we're in good shape. The EVA went very well. I'll talk a little bit about the future and then hand it to these guys to tell you more of the details. So with the EVA that we had to do today, we really couldn't squeeze in the HTV departure, which was originally planned for tomorrow. In between the HTV departure and the Soyuz departure, we had a reboost planned it's for phasing for future vehicles. It would tweak the landing a little bit, but that wasn't mandatory. But in working with the rest of the partners, we've decided that the plan is as follows. We will plan to have HTV depart on the 12th. We'll do a reboost to tweak the phasing of the orbit on the 14th, and then the 30 Soyuz will depart on time on the 16th. And that then puts everything in play to go ahead and have the ATV depart on time, which I think is currently the 25th of September. So hats off to the team. They did a fantastic job. This was a very challenging issue that took a lot of thinking about what do you have in your list of tools, and not necessarily tools on orbit that you can use to get yourself in a good posture to install this bolt. As it turned out, the bolt post had some rough threads in it, and since we don't have on orbit a tapping device per se, we had to come up with tools to kind of clean it out as best we could and then run this other bolt in. But the team did a really great job. The crew did a fantastic job outside today, and as a result of that, we're back in really good shape on orbit. And so with that, I'll hand it over to Ed.
Well, thank you, sir. I'll start with the end of today. Obviously, getting MBSU-1 installed and activated. Doing that successfully is a broad team across several organizations throughout the program and across the partnership to make that all happen. And I'm extremely proud and impressed with all the work of all the people that were involved in putting this together. Not only the EVA team, but they're the ones that are out in front pulling this together for the crew, but all of the different flight control disciplines that are involved, all the engineers, analysts, the folks at Kennedy Space Center that actually installed the MBSU into S0 before it launched. The press conference we had last week, Mr. Suffredini talked about going back and pulling paper on the actual initial installations. We did that. We talked to everybody we possibly could to understand what was going on, and that paid off here today in the end. I'll talk briefly about what's happened over the last 6 days. If you can believe it, today's only the 6th day after the end of the third longest EVA in U.S. history last Thursday. Since that time, even Friday morning, we had a skeleton plan of what we would do on a EVA that turned out to be today. We came with a bunch of questions. First, obviously, what happened, and wanted to understand as best we could what happened last Thursday. And then we went from those questions to try to, in broad terms, say what needs to be done to make us most successful on doing it again. So of course that meant go take a look at the failed MBSU, the MBSU we had been trying to install, and see if it had been damaged or if there was anything on that MBSU that might tell us some clues about what had happened. We also needed to clean that up and get it ready for installation. Go inspect the cold plate on the S0 work site where the MBSU gets installed. Make sure, see if there were any smoking guns out there to show us what had happened, but then also get that all cleaned up and ready for an installation task. From that point, the engineers and all the various flight controllers went from those questions to finding ways to get answers to those questions. So of course we looked at paperwork, we looked at previous tasks that had similar types of installations. For example, the battery charge-discharge units, the BCDUs, we've installed some of those in our past, and they have a similar configuration. We went and talked to all the people involved with those activities to learn what we could. We also, like Mr. Suffredini mentioned, we went and invented new tools that we could take outside to help us clean and chase the threads in the posts of the S0 cold plate, to blow out any debris, to look for damage, and to make sure that we fully understood and could correct the best we could the situation there at S0. We also had several very long discussions with all of our engineering counterparts to take the questions as far deep as we possibly could. What if we find such and such out at the worksite? What are we going to do? If this method doesn't work, what's the next step? So we really completely developed as much as we could what we call the crib sheet, or the what do you do if this happens paperwork. And that went very smoothly. Developing that was a long process. Several meetings went into that, but today's success shows the results of all those meetings and how fruitful they were. We had a great set of documentation. We didn't have to stray from it, and it enabled us to be successful today. So we call it a Team 4 effort, and that's because we're pulling out a separate team to go focus on all these. And it really was an amazing experience to be a part of and to watch as this entire team came together with its resolve to fix the singular issue. And then we did so with enough time left that we could go pick up one remaining scheduled task from last week's EVA, and that was replacing the boom camera. So I'm glad we could get that done as well. And over the course of these 2 EVAs, we were able to get all of our primary objectives for the EVA 18 accomplished. So I'm very, very happy with the success of the EVA, and I'll let Keith go into any more details he wants to.
Thanks, Ed. Let's see. So today's EVA was 6 hours and 28 minutes, which puts Suni at 44 hours and 2 minutes of total EVA duration, puts her 11th in the U.S. standings. And she is, of course, the #1 female duration for EVA. So that's kind of cool. And we let her know that during the EVA. She sloughed it off and said, "I'm just out here doing a job, and I'm in the right place at the right time." So has a wonderful attitude to have, to know that she's out there to do her job. Aki, that was his second EVA. It makes his total 14 hours and 45 minutes. He is the leading Japanese astronaut. He surpassed Takao Doi, who had 12 hours and 43 minutes. We went out the door with an off-nominal suit configuration from the EVA last week. We had a problem with the cooling on Aki's suit, and because of that, both crew members had to shift suits. Aki went out in Suni's suits, which was resized for him, and Suni went out in a large hard upper torso, which is an off-nominal size, but she had practiced in it before, and she didn't have any complaints and stuck ahead with the plan. So Ed mentioned a lot of the work that went into getting ready for this EVA, and I have to say I had many people come up to me and ask me what I thought the odds were of installing the MBSU under these conditions, and really the best that you could do is plan for getting the box in, but then also plan for all of the multiple things that you would have to do if we had to bring that box inside. Mr. Suffredini asked us to look at that several months ago with the failed box that we took out because there are plans to potentially change out one of the plates inside of that, the cards. And so we did have a chance to look at how well that MBSU fits inside of the airlock along with other bags. And because of that, we came up with a configuration that If we needed to bring everything back inside with us, along with both crew members, we had a safe configuration. So we had to plan for that. And during the week between the failure and this EVA today, as Ed mentioned, we had teams going off developing many tools to make our jobs more highly successful. One of the tools that we developed, we pulled out, we have spare boxes that are inside space station that are the same bolting configuration as the MBSU. So in order to understand what could have been wrong with the bolt, we scavenged the bolting mechanism out of one of the boxes that was inside and developed what we used as a tapping tool that Mr. Seferdini mentioned. This is a T-handle tool that the crew members use to restrain some of the outer coating on space station. It's a handling aid. It's got a pit pin on one end, and it fit nicely into, just fortunately fit nicely into the bolt mechanism. And so we could develop a tool that allowed us to drive the bolt without the box around it, so we could see just what it took to get a bolt installed. We also had to put tether features on it, and that allowed us to keep it safely secured during the operation. Well, we knew that the torque was going to be a high running torque, or we suspected that it was going to be fairly high. This is about what a gloved hand could do to turn this bolt. And because the torque could go up from there, we had to find a way to allow us to take this T-handle tool off and put another socket in place. So the guys on the ground came up with a really nifty method to cut this particular tool loose and then install a much larger handle that would then allow them to put quite a bit more torque into the bolt. And this was a really good design, and this worked out really well because the torque got to the point where neither Suni nor Aki was able to do it with the T-handle tool. And it also allowed them to drive it both forward and backward when installing the bolt. And that way they overcame the rough spots that Mr. Seferdini mentioned by driving it through those spots. So we, in the process, lubricated the bolt with lubricant that we've used on orbit before. This is what we call the lube gun, and it has brake coat in it, which is kind of a vacuum stabilized grease with some particles in it that allow it to, some graphite particles that aid in lubrication. We brought this gun out with us. Unfortunately, we didn't have to use it. In previous EVAs, we've used this gun to lubricate the solar alpha rotary joint and also the end effector on the arm and other points were grapple fixtures on board space station. So we had this on board. We used it to squirt into mitts that the crew members have for applying this lubricant. And with that, they put some of their other tools that we applied the lubricant to, such as the bolt that I mentioned before, and also an application tool that may seem familiar to people, which is a toothbrush. So while we were IVA, the crew took this toothbrush, attached it to another T-handle, and then put it in the grease and prepared it to go EVA. So the process that the crew used once they got the MBSU out and away from the stanchion, we knew that we had particles down inside the socket. So they came outside with yet another tool that was developed by the ground team. And this is a very interesting tool. This is a piece of cable that has the end wires bent back to make a bit of a brush. And they took this tool out with them to the work site. It has, on the end of it, what we can attach the pistol grip tool. So they put the pistol grip tool on it and then drove it down into the socket and then back out again. And in the process of doing that, they liberated a lot of the extra material that we suspect was binding the bolt. And they also had a chance to kind of feel how stiff it was driving it in and then driving it back out again. So it gave them some appreciation for what they had in store for them when they were going to drive the bolt. After that, we took the gas, the tool that you saw in the previous EVA, which is a nitrogen canister attached to a little nozzle, and they put it down in, and they bursted the nitrogen gas down in to blow out the particulate that was down inside. And then after that was done, we took the toothbrush that I mentioned in my little bag of tricks here, and we used this covered with lubricant and drove it down in and then back out again and lubricated, again, the socket, drove the bolt down in with the tools that I mentioned, and after doing that back and forth several times to get past those points, the crew members felt that it was time to install the box, as we did on the ground. We put the MBSU in place, and in this particular case, you saw before we were using a torque multiplier and a PGT. We decided that probably the best method for driving this bolt, where you'd get the most feedback, and you also have a good lever arm, was using our EVA ratchet tool with a socket attached to it. So the crew members put this into the bolt, and it turns out that this time we also came up with some methods to get the box in a neutral position, which allowed them to drive the bolt much more easily than we saw on the previous EVA, which proved successful. And we didn't have any other issues during the EVA. The suits ran very well, and the crew members had a good fit. And they're back inside right now, getting ready for bed, and we're very happy with the EVA.
Okay, we'll start out with questions here at the Johnson Space Center in Houston. Gina?
Sure, if I have time for one. So Mike, at what point did you breathe a sigh of relief today?
Oh, Gina, you always ask me these questions. Let's see. I didn't sweat too much when the MBSU wouldn't go in, because being down 2 channels wasn't too bad. But the last few days, every day as you were watching, we lost another power channel. We lost a thermal loop, at least briefly, in node 3. And we had another hiccup that's evading me right this instant. But we had a number of little gotchas come up. We had a normal health flag on MBSU 2 over the course of a few days. And so things seemed like they were adding up. So once the MBSU went in, that was nice. But when they powered it up and said it was a healthy box, then I started to feel a little bit better.
And for Ed and Keith, when did the toothbrush come into play, and whose bright idea was that?
Wow.
You know what, I mean, I heard it come from 2 different directions. So I would like to say that at some point I suggested it, and I don't want to take credit, because someone else came in and said, hey, we just tried the toothbrush over on the fixture. And I thought, did someone hear me say that, or did they come up with it on their own? And I have to say, you know, there are lots and lots of brilliant ideas that come up with people, and it's always those ones where, you know, you take something common that everybody understands and use it in an off-nominal situation that just really makes you appreciate where you work and what you do. We were concerned that this wasn't going to pass thermal vacuum testing. So as part of the whole preparation for the EVA, you know, we send teams all over the place because we look at every aspect of things that could go wrong, or how you could get it stuck or cause more damage with the piece of hardware that you're taking out than good. So we did put this in a thermal vacuum chamber and found out that it could stand the high temperatures and the low temperatures. And we were still a little nervous about the bristles or it breaking off, but the crew was very careful with it. So we're very happy about that.
Thank you.
Can I just add, if I can? It was really amazing to watch the ingenuity of the engineers involved in the flight controllers. And they would come up with this idea of, hey, let's stick a toothbrush in there. And from there, it was like, okay, well, if we're going to do that, it has to have this. It has to be long enough. It has to be tetherable. It has to be something that a gloved hand can interact with. we have to be able to spin it and keep control of it. And then right away, just all this wide variety of ingenious people. Oh, well, if we put this, the tape on it, for example, that'll keep it all together and keep it within the thermal. And we'll put this particular tool on it so it's got a tether point, and that makes it the right size. And then, you know, we would go through a couple prototypes really quickly and go over to the mock-up facility and try it out. And there you have it. We have the tools that you see in front of you. It was amazing to watch it all come together.
Robert Perlman with CollectSpace.com. So do these makeshift tools now become part of the permanent spacewalker's arsenal, or does it now inspire a team on Earth to go formalize and actually build a tool that does the same job to be launched on a future mission?
For the near term, at least, they will certainly become what we consider to be hip pockets. We certainly won't throw away the good work that we've done to assemble these if we need them again. My guess is that the crew will take and keep them somewhere staged on board the vehicle. I don't believe we're going to build any more before we need them again. I wouldn't be surprised, though, if there isn't a team that goes off and, you know, we're going to have a lot of post-flight that goes on with this, and make sure we truly understand what happened and how we should be postured. And if we decide that this has applicability across a wide range, if not go build and fly new tools, then certainly we'll consider ways to better our posture in case, before it happens the next time, even if it means just assembling something on board.
Well, yeah, for instance, these boxes are very common, so the batteries have this same 2 Acme bolt solution. The MDMs that are installed have in fact, this bolt came from an MDM that's stored inside that actually is for use outside. So one of the things we all wished we had was a tap to follow the threads down in case they were boogered up. And so that was already on our list. In fact, we were planning on flying that on the next SpaceX flight. That was already in our plan in case other things didn't work out for us. So as Ed said, you know, you look at the things you wish you had on orbit that perhaps will do that job better, and we'll probably think about that in terms of we have a lot of ORUs outside, all of them have this same interface, and what are the set of tools the crew should have when they go out to this next one, just to see, to make sure that you don't have to come back inside. You can do the things you know you need to do if the threads are not acting right for you.
I'd also like to add to that the tools that we use in most cases, we try to use ones that are already EVA certified. So these do have a use for them, and we'll probably deintegrate what we put together. These are now covered with grease and particulate that we want to keep somewhat isolated. So we'll take those probably out of the inventory, but at least consider, you know, where they are for a future EVA. I'm not sure which particular crew member the toothbrush came from, but they're going to want it back. So.
And just in a larger sense, more than 10 years into the station's life and 165 spacewalks, did you at all anticipate that bolts were going to still be an issue this far into the program? And what does it say for looking out, you know, towards the out years?
Well, you know, we didn't really talk to you too much about what causes this problem. So during the EVA, the team got to the point where they were trying to use technique to get the box down. And this is not the first box like this. We did 6 batteries, which have the same interface. And so really this was a combination of technique, but that the bolts, we found this particular bolt, as you may have noticed watching the EVA, this particular bolt about 4 turns in got stuck, and we really couldn't get past about 4 turns during the last EVA. And when we ran this bolt down, we found this spot in this area. So this doesn't have to do with how long it's been on orbit. It really has to do with when we installed them. When we installed these particular MBSUs, and this one in particular because of the face of the truss it's on, and I think I mentioned this before, this really, we weren't able to rotate the S0 truss. So the ground crews had to get on a scissor jack. They lift up as high as they can. It's a 220-pound ORU, and they're in a 45-degree face facing up, and they're trying to get it up here, and then they're trying to torque it and wiggle it and torque it. So we're not completely surprised that the threads could be a little gummed up. Again, you can't cross-thread an Acme bolt, but we think we galled the bolt, which is not an uncommon thing to have happen if you put torque, off-center torque on it while you're trying to torque the bolt down. So we believe, just as a normal course of installing some of these ORUs, particularly ones where we couldn't put the truss in a position where it's easy to lower. In the case of the batteries, we always rotated the truss and we lowered the batteries down and put them in place and then torqued them down. But in the case of these MBSUs and some other components, we weren't able to do that. So part of what we'll look at as the future is which ones do we expect to have trouble with, which ones might have slightly galled bolts, so that we'll know to, just expect to plan the EVA around chasing the threads or whatever else we think is the technique we need to use. But this isn't an age issue. This just has to do with the way we had to install on the ground and what it ultimately does to the interface when you install it that way.
Okay. That's all our questions for now here in Houston. We'll go to the telephone lines. I think in order of call-in, Jim Oberg with NBC.
Yeah. Hi, Mike. Let me turn off the TV here. There's a little delay. I want to ask you to go back and look at the big picture of the big 14 failures, and this was one of the big 14 that they fixed. But isn't there another big 14 already out there in the weeds waiting for you? And are these so far of your big 14 list in the past 2 years? Is this the second and third failures, or were there some more that we didn't notice?
Let's see, Big 12s. Well, that's an interesting question because it's 12 now, by the way, and we think we've settled on that number. So, as you rightly recall, the MBSU and the pump module are both on the Big 12 list, and we've learned even more about installing these kinds of boxes. We have particular MDMs that are on the Big 12 list. We have the fluid hose rotary coupler, which is the coupler that the radiators rotate around. It allows the fluid hoses to rotate around the radiator and get the fluid to the radiator, so that's one. So we have this list of 12. We're working through them. Now, part of what we're doing is reviewing the procedures, making sure the procedures are well potted. Before, we had procedures and we thought we understood how they went, but we hadn't done a lot of pool runs. We hadn't spent a lot of time trying to figure out the techniques. So we just made sure we were able to do the steps we thought were necessary to change out that component. So part of the work being done on all the Big 12s, and we've got a little ways to go, is to run these in the pool, make sure we understand the techniques. And the other, to me, more critical is to understand how you're going to work around that interface until you make that change so that you stay in as robust a position. Remember, on the pump module, one of the challenges we had was we couldn't cool the arm. We're supposed to have redundant power in the arm, and we had to do a lot of work to figure out, well, actually we could provide redundant power to the arm with an uncooled DDCU, and we had certain jumpers we used to put ourselves in a more favorable config. So that's probably one of the biggest things we're having to work through in each of these is how do you get yourself in a more robust posture just to survive, but also to make sure you can go outside, which takes certain power to the airlock and certain systems. So you can get yourself in posture, go outside, use the systems you normally use to do the change out. So whether we've done more than 2 of the Big 12s, I don't remember off the top of my head. I don't think so. But as you can tell here, MBSU was on there. We've done quite a bit of work at MBSU, but we've also learned along the way. I think this EVA taught us more. I don't know if that gets at what you were pulling on, Jim, but hopefully that helps.
Switching unit that failed, that used to be on the list I had, but maybe it's been taken off.
Which one?
The DCSU.
I don't remember if the DCSU is on there. SSU and DCSU are on there?
We took it off.
Took it off, yeah. There you go. Well, we're living through a DCSU down actually right now.
Yeah,
it's not completely down, but an RBI is down. But I just don't remember the conversation. But I suspect it has to do with prior to that. We weren't as robust. We had very few power channels in the early days. Now we've got all 8 channels. So right now, like we're saying, we're breathing a sigh of relief. We've got 7 to 8 channels. And so one channel down is not a position we want to be in, but it doesn't send you into really worrying and having to rush out the door.
Mike, we're just checking it out, but again, hats off to the IFM group, miracle workers in the great tradition.
Yeah, Ed said it really well, and I've, You know, it's a treat for me to be the program manager in this program. The number of people that were involved in coming up with ideas, and the folks that actually took those ideas and put them in shape tools around what crews could do on orbit using the stuff we had on orbit. It was an amazing thing to watch and behold, and Ed deserves a lot of credit. He brought a big team of folks together, not just the ops guys, but the engineering guys and the MER. As he said, you know, the techs we called techs. One of them was in retirement that spent a lot of time talking to us and explaining to us the challenge. The whole Boeing team was involved. It was a great effort. These guys have the experience and the dedication and the attention to detail that you have to be successful in this environment. And sometimes they make it look a lot easier than it really is.
Yeah, atta girls and atta boys all around.
Mm-hmm. All right, thanks, Jim. On to Mark Carreau with Aviation Week.
Yeah, thank you, Mark Carreau from Aviation Week. Could you provide kind of a status on the DDSU power trip on Saturday? Is that something that will require a spacewalk ultimately to repair, or is that still being evaluated?
Well, first of all, we got to figure out exactly what trip. So, and Ed might have more. So, Ed, jump in when you're ready. But the what happened? What did trip was an RBI in the DCSU, but it was a reaction to something outside the DCSU that occurred, either in the sequential shunt unit, which is the solar array feeds power through the sequential shunt unit, or it's in actually the beta gimbal itself. We refer to it as a broom, but it's the rotating device that the power then goes through on its way to the DCSU, and then at the DCSU it's distributed to the different locations to provide power where it's supposed to. And so the DCSU reacted to what appears to be a short. It was a very high negative current, short-lived negative current draw that tripped it. Now we have insight, and we can see that that short is not there anymore. So even though we're not providing power, what we have to figure out is, was it the SSU or the roll ring, or is there some wiring issue in between, which is hard to believe something like that would be momentary. So we have a lot of work in front of us to try to sort through that. When we kind of set it aside, we're keeping power to the batteries. We've got them charged. I assume they're charged up now that we have the insight. And we're keeping all the systems on the IEA in good shape while we wanted to get through this EVA and then think about what we need to do there. So whether we have to go outside or not, I don't know. We'll have to finish going through the fault tree and see what we think the cause was, whether or not this temporary occurrence is something that is now we can assume won't happen again, or if it's something we think is about to happen again, what posture we need to be in for the future. So we've got a little bit of work left to go on that one. Ed,
I give you a little history on the operations that we went through from the time of the trip until right now. The first thing, of course, the first thing we do when we see something of that nature is it puts a big red warning up on our caution and warning summary, and we have procedures in place for any of those warnings. So we took appropriate action to first just make sure that the vehicle was safe, the channel was safe, and moved on from there. The first thing we wanted to do was isolate the upstream components, which, as Mr. Saffredini mentioned, is the SSU and the broom, from the downstream components, and that is the batteries themselves, the thermal loop that the batteries are cooled under, and then the MBSU, and in this case that was MBSU number 3. And in this particular situation, we're talking about DCSU 3A is what we're referring to, and the DCSU is the box out right under the solar array that routes all the power down to the different loads. We wanted to isolate that box from the solar array itself and the batteries and the loads. So once we took care of that, we could make use of a function that exists in all of the MBSUs, and that is we can actually tie 2 channels together. So we tied the 3B channel to the 3A channel, and that way the fully functional 3B solar array could provide power to not only its loads, but then also the loads that are all normally carried by that 3A solar array. And that included not only powering the loads underneath that MBSU, so all of the end loads, but it also let us send power back up into the truss, and we could actually, like he said, charge the batteries under the 3A solar array. And so everything underneath that DCSU is currently being provided power from its next door neighbor, its sibling power channel, the 3B power channel. And the solar array itself is still being controlled. Its computer is called the Electronics Control Unit, the ECU. And that is still functional. The array is still tracking, but is currently in a mode that we call being shunted, in that none of its solar power is actually being routed anywhere. So it's not actually collecting and converting power for our use. But it is tracking just like we want it to. And so it's in a safe configuration. And that's what we were really going for to get ready for the EVA today. We wanted to get 3A safe, to be able to power all of its loads. And then we wanted to understand how to operate the vehicle with 3 power channels offline, the 2 serviced by MBSU-1 and then the 3A channel. So we got all of that worked. We looked for any problems that we might have with that going into this EVA. It only required some minor changes to our plans for doing power downs, but then we were able to press into today's EVA. And the goal was, as soon as this EVA was done, start doing all the work that Mr. Suffredini talked about in assessing how we can get the 3A channel back and what needs to be done there. It wouldn't be surprising to me if the team isn't already meeting to start looking at that problem now that we've got MBSU-1 up and running. That's just the engineers involved and the team involved, is that once the problem's behind us, we just move on to the next thing that we have to take care of, and we keep the laboratory running.
Okay. Anything further from you, Mark?
I'm good. Thank you very much.
Okay. On to Marcia Dunn with AP.
Yes, hi. I was wondering, when do you expect to be back up to where you were, so to speak, not counting this latest problem? Just, do you expect to have all the systems back to be on the proper circuits in a day, or are they already on that way now?
Well, I can talk the near-term plan as far as reconfiguring the systems. The immediate response, we've already got the MBSU up and running and providing power to the DC converter units underneath it. Like we talked about last week, some of those converters are the only provider of power to some of our avionics, and in other cases, those converters share loads with what we call parallel DDCUs being powered from other channels. So when you have the 2 DDCUs together sharing the loads, we have repowered those DDCUs, and now that 1A and 1B power is jointly feeding all of the loads, and so that is a nominal configuration. So that's normal. 2 of our primary load carriers are DDCU 1 Bravo and then also S0 1 Alpha. And what that is, one side powers half of the avionics in the US lab. The other side powers things like one of our external thermal loop pumps and one of our S-band strings. Right now, all of those loads are being powered through jumpers, and we talked about those last week and how we've rerouted power through those jumpers. Now, over the next 2 days, we'll be removing those jumpers, and that will get us back into the standard configuration. So tomorrow, we're going to remove the the jumper that's providing power to the internal loads, and then on Friday, today's Wednesday, on Friday, we'll be removing the jumper that provides power to the external loads, and then we'll be back in the normal configuration for the MBSU-1 serviced loads.
Thank you. And one other question. I think I may know the answer, but did you say that this was a defect that was introduced on the ground prior to launch, the fact that all these metal shavings were in there jamming the socket? I'm just trying to get a handle on how this actually happened to begin with.
Well, it's I don't know if I'd call it a defect. As a result of how we had to install it, we think we probably galled the bolt as we were installing it, and so the result of that is you damage the threads a little bit and you leave shavings behind, and that's likely the source of the shavings that we found and the trouble we had with the post threads. That's speculation, but it's a pretty good guess. It'd be hard to do that kind of. We just removed the bolt on orbit, so it'd be hard to leave that kind of that number of threads. That amount of shavings that we saw with the little bit of work we did on orbit. So that's the speculation.
Thank you.
Okay, next is Todd Halverson from Florida Today. Well, not hearing from Todd. Denise with Space.com.
Hi, thank you. I think it was Jack Fisher in Mission Control, once the unit had been installed and powered up, he said that when he was congratulating the crew and the team, that it felt a little bit like being on the set of Apollo 13. I was wondering, Ed or Keith, if you could describe what kind of tension you were feeling in Mission Control today and also in the days leading up to the EVA.
I'll start. There's one thing with Apollo 13 and the issues that they faced. Obviously, that was life-threatening to the crew, and the efforts that they were working through then was how to get the crew home safely alive. We obviously weren't in that situation. But what the similarities really were there, though, to watch how the team came together. Just the scene that comes to mind from the movie, and we did make jokes and talk about Apollo 13, and failure is not an option is certainly something that I mentioned a couple of times because we had to get this thing installed. But the scene where the engineers came in and dumped a box full of, here's the stuff they've got on the vehicle, let's figure out how to make this work for their CO2 scrubber. We didn't use any socks, but we pretty much pulled a bunch of different pieces out of our pantries and put together an amazing set of tools. And the free flow of ideas from any corner that might have helped us. It was just like it was in the movie and then also in real life. The dedication and professionalism of everyone involved. And something else that I don't know if it's easy to pick up in the movie, but if you watch the movie or if you know about the real life story, the age of the flight controllers, these are all young kids that are doing this amazing work. And the same was true in our story. The younger generation of flight controllers that were pulling these things together, assisted by the seasoned veterans that have been through things that included first element launch, watching them pull together the amazing things that we did, that they pulled together that allowed us to do what we did today. Really did come similar to what it must have been like to experience Apollo 13, although we weren't allowed to smoke cigars in the end, so I think they still had it a little better.
Anything else, Denise?
No, that's it. Thank you.
All right, we'll move on to Phil with NASASpaceflight.com.
You guys already covered everything for me. Thanks.
All right, Bill Harwood, CBS.
Yeah, just one more DCSU question for Ed, I guess. Are there any operational constraints to being one channel down or one array down, I guess? Do you have to manage anything because you don't have all 8 running, or is it just transparent at this point? Thanks.
Well, you know us, so we have flight rules for everything. So there are definitely constraints for operating in the configuration that we're in right now. The constraints are a lot lighter now that we have MBSU-1 up and running, and once we get back into that fully normal configuration, we will be in good shape. We talked a lot last week about power balance and power loading, and we're still going to be in that situation where we have to manage the amount of power that we put on the channels and make sure we don't do something that might trip off either the 3A channel or the entire 3A and 3B channel, because now we have those two things tied together. We have the power recess officers. It's a group of folks that analyze all of our power loading, the solar angles, where we are in the orbit, and they tell us what our forecast power usage is. Obviously, we've been putting them through the grinder for the past week, and they'll continue to make sure that we stay on the right path as far as our power balance. And then we do have to make sure that we manage the batteries, for example. We mentioned that the 3A batteries are being charged through the 3B solar array, but because the 3A and the 3B channels are tied together, the 3A batteries aren't going to be taxed as much as they otherwise would be, because the 3A and 3B batteries are sharing the loads. And so there's actually a potential that we could hit the upper charge limits on those batteries if we continue to just let them charge. So we have insight into that, and we might force those batteries to be used just so we keep their charging levels down to where they're, I think 105% is where we try to stop them, somewhere around there. So we just keep them, make sure they keep discharging as we need to. On the scale of what we've been working through the last week, though, this is going to be a bit more manageable for us. We should be able to take care of this without any problems.
Thank you very much.
Okay, last but not least, Irene Klotz.
Thanks very much. Most of my questions have been answered. I just was curious if you guys have a target launch date for the SpaceX flight. Thanks.
For SpaceX, it's interesting. It's one of these things where we try to manage our readiness for the vehicle given the availability of the range. So they have the range today on the 9th and 10th of October, and we're prepared to support that. However, they could fly sooner, and we'd prefer them to fly a little sooner to just keep ourselves deconflicted from the Soyuz flight that's coming up. And if they slip from the 10th, we've got to go to the other side of the Soyuz flight. So what we'd like to do is try a little earlier if we can. I think there's an Atlas on the range. So we're ready to fly. They'll be ready to fly, as my understanding, as early as the 5th of October. And we'll be prepared to take them on the 5th of October, but right now the range is occupied on that date. So if something changes on the range, then we'll try earlier. Otherwise, right now we've got them, they're on the range for the 9th, and we're prepared for them to arrive after that launch.
Okay. Well, not seeing any further follow-ups here in Houston. We'll close this briefing out. Thank you very much for being here today. Remember that all the latest information on the International Space Station is available on the web at www.nasa.gov. Thanks for coming.